Hey, this is James. This is part 2 of working on the burnt 450 SL. So I found some interesting things out. So, I told you in the last video, if it made the cut, that I bought a LS1, LS6 tube real cheap off eBay to see what I need to, how I need to make the tube and everything with the AN fittings and everything that's on it. And as I was messing around, I was joking, there's no way this tube is going to fit. Guess what? It fits 3, but not this one here. So these aren't the exact measurements, and I will probably follow up with a better, but basically on center, we're around 112, 113. Now these move a little bit here. And so we got 112 millimeters, 112 millimeters. It matches up perfectly to the first 3. But then we come down to 68 millimeters to this one over here and this one over here. So you can't see it because of the way the camera is, but this one also fits over here. So what's the possibility of doing is sectioning it here and here, putting it together and welding it, and then re-anodizing it and drilling one more hole back in the spot, and we have a very cheap, $40 for this and the AN fittings in the cross piece, and everything looks like it works, but we'll see if we go that way. I gotta get my son some argon to do the welding, to section it, or I gotta find someone with a TIG welder that will do it for me. So next thing is I'm going to start taking out everything else. I went ahead and drained the water out, and because the cross member here, just like in a good old V8, all the other American V8s, there's a water cross member here. And so I've already drained that water, and I'm going to I did a bunch of research on these different valves so I can keep the emission stuff going. And this one over here, this 3-valve vacuum transducer, we need to test it. This one luckily is going to be replaced by the EFI. I need to 3D print an end for this or change it out to a maybe like a turbo a wastegate actuator to get this guy to work, because it has a hole in it right here. I can see as I move. And all this does, that's the hot water pipe. I found one of these, so it's on order. I got to see what else I got to order here to make all this come together. It's getting kind of hard to find parts, actually. The online auction site has a lot of stuff, but this one, which I'm afraid is messed up on the inside, doesn't. The purge valve that was underneath it here, I don't know why that would have started a fire, but I did some lookups, and it can. It's basically venting the bottom of the throttle here, and it had to be that unit. I mean, it's kind of weird that a purge valve, it just sends the fumes back through the canister, back to the tank and stuff. And it's a bunch of control valves. So I think this is an electrical one that got burned up in the fire. Went ahead and clipped a bunch of stuff here. That line there is it's 200 and some, or 100. Hopefully I get it for 100. This guy right here, had a hard time figuring out what that was. Finally, in the Chilton's manual for the car group, all the 450s, the sedans and stuff, I was able to find it. And I'm pretty sure this is a 104-degree switch for cold starting, or hot starting, excuse me. All right, I got to keep these two going. These are thermal switches, vacuum switches that turn on and off. So going to keep those. I thought I had to remove them, but I'm going to go ahead and keep those. And then I need to come up with a idle air controller, and I'm going to reuse this piping for those 2 spots there, and I think a Ford IAC for that. So now all I'm going to do is just start popping this stuff out. I mean, this is, these are pretty much it, just one, it should be finger tight by now. Oh, there we go. All right, and then yeah, carbon buildup. So these come out too. I got new ones of these, but we're going to reuse them for our other stuff. Right now I'm just going to put them back in because I need to get the manifold off, and that's going to be boring, and I'm not going to show you. So the water pipe here, I disconnected this to let this go. We'll have to put a fill plate in on that, and I'm going to go ahead and take those vacuums off the firewall, and I'm not going to film that. I'll show you after everything's done, but this is a closer look up. Pretty sure you get bored watching me pull all this stuff off, but we're going to test we're going to look at them, see what we can do. As I was putting this together, I noticed these next couple clips, the audio failed on me from the setup I had on the lapel mic. And so I cut everything down here just to a minute because I can't remember what I said. Probably just droning on anyway, right? Looking at the back of the firewall here, probably talking about what I had to take apart, or right next to where some of the hot water intake, or where it comes out, goes back into the engine from going into the cabin, and then I pop out the manifold and plenum here, and then I show you how dirty the valley is. Yeah, getting ready to clean this up. Take that off, and what the heck? Well, check this out. This whole port's been blocked. It's like this waxy type substance for this water. What if that stop leak? I don't know. Someone tell me. It's very curious. I'm trying to figure out the fuel replacement thing. Fuel injector. I've been trying to find out the fuel injector replacement. So this is what the stock looks like coming from the mechanical spider hard lines, and we can see here it doesn't quite go out. So I was working on just coming in from the top and finding one long enough, but I got to watch out on the duty cycles. Well, not the duty cycles, excuse me. I have to watch out on the how many pounds per hour I'm flowing. And so I calculated I can run at 20 without affecting the fuel economy and giving some headroom in case I add that supercharger on. Not really. But so this is just a standard Ford V8 from the 90s injector, very cheap, but great. I run it in my Jeep as an upgrade, and it's perfect. It's a conical, 4-hole conical, and so it's spraying the way that we need it to spray. You have to watch when you're figuring these things out, and sometimes they spray conical straight down, other times they can spray that way or this way. And I'm not gonna mess around trying to re-engineer that. I want to get as close as possible to what the engineers designed. So I found this from Delphi that runs on I don't have it in front of me right now, but on on Chrysler products. So it's same body. It's a EV6 generation. It has enough, it runs at 80% duty, which is pretty darn good comparing what it come from. But this almost comes up. So if we look at these two, it's almost a perfect match. So it doesn't come out the end, but it's like it has a little shroud around it. So, so I took a drill mill tool and I cut this, and this was a lot thicker than I thought it was going to be, a little harder to cut. This thing is pretty tough. I thought it was just some cheesy plastic. It's pretty good. It's very good stuff, made very well. So we're just reusing it, but unfortunately, up here when I first started testing it, I had a full 14 millimeters here. So all EV6s are 14 millimeter top and bottom, but it cones down as we go lower into it. So I'm sitting at about 12. So that means I gotta get a 14 millimeter bit or a 17th 32nd one and just go about that much deeper into it to get the O-ring work. So now, we'll have this, will press in, and it'll be hard to get back out. So it's gonna, we're just gonna go in right down to that black spot there with the drill, and just wall it out a little bit. And I might remake these things on a 3D printer and make it so you can pop them out and play around with. I actually want these things instead of this. And the reason why I don't want this is that it's a 27 pound per hour, which puts us past our 20 by more than 30%. And the reason why that's a problem is that the fuel injection can't tune down that low during idle. And so when you're running a lot of your stuff, I'm not building a horsepower engine here. So, it's just going to be a stock engine to 225, if it's even still that, and then adding, hopefully with the fuel injection, with the EFI, I'm going to add 15 horsepower to it. No idea. Maybe it adds nothing. And so I don't want to get too much overhead in there. So I like this one. And I wish I could get it in the 20. I'm going to do some more research and to try to find the extended tip. Right. Well, I guess this is as far as it would go, push in without heavily modifying that. So I don't know. You get this, make a rendering of it, and maybe I'd make a different bung that's going to be out of ABS or carbon fiber. I just want a way to be able to pop it out without having to take the manifold off. But the more I think about it, it's not, you just only have to change these O-rings every 100,000. And, this project's not going to last that long, I doubt. It's not like I'm going daily at every day. So that's where I'm at right now on figuring out the correct fuel injector. I'm going with late 80s, or excuse me, late 90s stuff. Technology really, Mercedes was pretty far ahead of its time with, or Bosch was, with putting all this stuff together. And that's why Bosch is still king. And this is, 20 years newer, but still 20 years old. It's not like, I can't even go with brand new stuff because, the computer control has gotten even so much more, direct injection and all that stuff, that, this is a great mod. I can go out to the junkyard and get parts or get these off eBay pretty cheap. So this is 14 bucks off eBay, $14 off eBay. Now the project's starting to come together. I just got my delivery from DIY Auto Tune. This is where, I got the better version. I got the amp version of the computer. So this is a MicroSquirt. It's got the better amperage on the fuel circuit, going from 5 of the old MicroSquirts to the to 14, I think. Pre-made cable. You know, this is going to go to all the sensors. It's going to go to the cop ignitions, and it's going to go to the fuel injectors. So we'll make that. $25. Already comes with all the fuses and the relays. It's more than most people need. I was planning on doing some other stuff, so we'll be taking, I think I only need 4. You know, basically ignition to turn on. Going to be for the fuel pump. Maybe separate igniters there, purge valve, and because the purge valve's going from a vacuum purge over to an electric purge, and then a fan. Even though the fan kit came with its own, it's all going to be wired up in through there. And then the other expensive item here is, all this is about $560 U1. So that's what ordered. And then standalone a Lambda unit, or a standalone airflow. I can't think what it's called right now, but this is your standalone. So I'm replacing, you know, the car. My version of the Mercedes has the has an O2 sensor in it, and you know, this is going to go to standalone. Here's the controller gauge. So the controller is then going to wire over into here. You know, it's going to come into one of these circuits up in here, and so that's going to, you know, automatically tell what the fuel ratio is. All right, a little crisscross applesauce while we play with cars. All right, here's the intake manifold. Underneath the plenum, I have it taken apart, getting while I'm in there, getting new gaskets there. And I'm waiting for those to come in. So one thing we need to figure out is a couple things here. So we have the, here is the stock throttle body. And it's got three vacuum signals off of it. But this side here is going to be on top, on the outside where there's no, at natural air pressure. And then this is underneath that vacuum pressure. And so it measures from in here. This one measures from up here. Right now, I don't know, usually you can see, and the throttle linkage. So what we need to put on here, at least, is a throttle position sensor. All right, so, you know, what position the throttle is in, you know, that's wide open and that's shut. So we need to be able to tell the computer where we're at. Okay, Ford, this is the throttle body off of Ford, paid $50 for it. I also got the IAC for it, which is air idle controller. So this, on our cars, it's vacuum. You know, on anything newer, it's electric, and it basically controls air between atmosphere and between vacuum. So you can see where, you know, one goes, it just lets air in while it's trying to idle. So when you go wide open and then all of a sudden you have to stop, this keeps the car from the idle going. It controls the idle based on more airflow, where it bypasses, you know, it does kind of a throttling of it with the solenoid that's in there. On our cars, you know, there's a whole setup thing. I think I got this set back up right. So this is the full idle control system, cold start. So a lot of this got cooked. Again, so this is the main controller, goes to the computer, uses vacuum here on the bottom and the top. That's the signal off of this hose here this is into the water jacket and turns on and off. Then it goes down to this little manifold. This is the cold start. Cold or hot start, I can't remember, but it's a fuel injector basically. So it's basically got a EV1 connector, so the original Bosch connector you see on most cars, and then the air runs into that part of the manifold there. So all that system is that little IAC on the Ford. I have it in the parts cleaner right now, that we can get rid of. That I need to compensate for it. You know, this is all all analog controlled by air, a little bit of digital by the computer, but when we're done, it'll be totally digital. Then this is the purge valve. It's working off the signal. This is actually where the fire started in this line, believe it or not, back up in there. So it burned all the way through there. These are charred. Luckily, I can find them and buy them if I was going to rebuild it back to stock or reuse these circuits for the computer controlled idle control air valve. But I'm ready. So this is off a Mercedes M53. Basically, I'm going to be controlling the purge valve. And I had it all worked out in my head, and I probably should have wrote it down at which point. But basically, yeah, so we're just looking at an analog circuit here of how the car works. So, so this is the air pump, which is down on the passenger side that pumps air into the exhaust. And, you know, it's basically based, it comes off the bottom of the vacuum side, and this switch, one of the switches on top, water controlled again, that's a check valve. When it's 70 degrees or 100 degrees or something like that, it's one of the valves that you see here. It basically turns on and injects air in there and makes your emissions better. I'm getting rid of the distributor, and so I don't need any of the advance there. I'm still keeping the EGR because I do like air. I do like clean air and stuff, and I do have to pass emissions out here. Even though I'm doing massive changes, hopefully I'll pass on the visual. And then here is the canister and the purge valve. So the purge valve, the gas line the purge ran over here to the front to the canister that sits on the driver's front side. Again, that's where the fire happened and just melted everything and cooked the fuel distributor. And so I'm going to basically, I had read how it worked, and I was just going to do a computer controlled based off of temperature of the motor. Basically, after it comes up to heat, the relay is going to click on, and it's simply going to go to the purge. It's going to be purging gas or purging stuff all the time, and hopefully that's enough to do it. If it's, I can use this. It sits up a lot higher. This is a 65 on both sides. This is off a Ford 4.6 or liter V8. Well, basically, you know, the same size family, about the same horsepower, and so that's why it's so close. Here, they still have a little bit of a venturi going on here for a wider stack coming in, but on the Fords, like the 302s or the 5 liters or the 4.6 liter motors, it's all the same 65 millimeter size. So I 3D printed a guide tool. It's just it's on the outside. It's 65 millimeters, and what I can do if I want to use this one in its place and not make one or modify this one with the throttle position sensor. Basically, you can see how the whole alignment looks. but you can drill holes right through there and mount the Ford on it, no problem. All right, so there's a lot of modding we got to do here. Base plate on there instead. And then this part needs to be sectioned for that tubing right there off the plane. So this either needs to be run, you just either need to take your cutoff wheel with a death wheel and cut it away a little bit, or put it through a chop saw type deal. And then they make repositioners on this because the angle at which this is going to sit here is going to interfere up here with all this stuff. So it's not, but I can also model it. This is pretty easy to model, just that shape, and then extrude it and extrude it out and then twist it in Fusion 360. And I only have to figure out how to get that bolt in there. But then I can have it, I can lay it down, or I can buy one of the relocates that basically has a plate on each end. The next thing is, I could go the easy route and just go MAP, which stands for mass airflow pressure, which I can just on the vacuum side, you know, anywhere where there's, I can put a GM MAP sensor on there. It's about 90 bucks. Seen them a lot cheaper. Probably go get a junkyard one for 20 bucks. And then, you know, it tells the computer what's going on. But this one's even better. So for 20 bucks, this is also off a 4.6 liter V8 Ford. I think this was off a 5.0. But everything is the same. It's the same diameter. Everything is 65 in the middle, so 3-inch tubing. We'll connect it all together. And, you know, you can either reuse the housing or you can make your own. And I'm basically going to be making my own from here up to there. That's going to mimic the barbecued fuel distributor. So this guy, main point of the fire is right around there. So this puppy's all charred up. I'm pretty sure everything is melted inside of there. The metering flap doesn't return like it's supposed to. So the measurements we need to go, I want to keep it looking stock underneath, on top at least, just because, or Colorado, and it's a carb state. So I'm basically going to model in 360, basically a tube that basically I'm going to start with a circle, and I'm going to use the loft feature to extrude out the circle to a larger circle. So this goes like 3.5 to 5 inches up in there. And then I'm going to make, off of these attachment points here and here, this flat area there, that's where the LS1 coils are going to go. You don't need to do LS coils, as I may have said already. I think this ignition that's on there is already powerful enough, but hey, I just want to have fun. And so we're going to be relocating. I'm going to be putting the coils in here. I have 2 of these, and I'm going to basically 3D print a plate and the intake in there. And also in that, I'm just going to take this sensor off and basically 3D model that point in there where this 6-pin math can then be put in right here, and then the regular right here, the regular air take will be on, and everything will be covered, and no one will know, except for maybe the fuel rails out here, what coolness resides underneath there. But also, I've seen other guys, when they've done the mod, they basically come up off of here and run it out that way to a cold air intake. Well, it's not really cold air since it's still inside the engine compartment. But you can definitely come up, put the mass airflow in there, or just go with a straight up map sensor. Go with a straight up map sensor. Cap this guy. There's actually caps you can put. You can probably do it all with silicone tubing and some other stuff, and not have to really mod, anything else. Just 3 inches right off there, come over 90 and into a K&N style air filter. So that's what we got going on here. I'm gonna start measuring out stuff and writing it down. All right, we just did a little bit of transfer work there. Luckily the part was dirty. I just put it up against there just to get the basic what's going on. Flipped it over, scraped my pencil on the other side, and there we go. So now this will be pretty easy to, I'll just measure it out. All right, same thing here with the throttle position sensor. Just a good old paper and a little bit of scribbling. We get the outline of it. All right, same thing here. It's time for a shadow puppet theater. Not really sure if this is going to work. I did go ahead and measure those holes out, and they're not square by any means. There's a tilt difference to them. I mean, these two, they're not holes, I should say, these bolts. You know, it almost looks like it's dead center with the throttle body, but then you look at it a little bit longer and maybe not so much. So what I'm going to attempt to do is get a good shadow that's not projected incorrectly, and repeat kindergarten, or I don't know, maybe we did this in 3rd grade, and basically sketch out. You know, I've already drawn a circle around where that's at. So I may be out because the shadows are just diffusing all over the place. It's at about 5 millimeters off inches. And I'll probably have to do a couple prints of this, just in cheap PLA. So I'm going to do a couple measurements here. Let me set this guy down. Hopefully everybody can see. About 1 inch. Located. Yep. This is 5 inches, and this one is okay. I think I have enough to make something. Looks pretty messy, and it is. So luckily I can read my chicken scratches. All right, the last measurement I need to take is the height. So when I put it into Fusion 360, we're going to start out with just a circle down there, and I'm going to do an offset plane up to whatever this is, 5.5 inches. And with other mods that I'm doing there, it'll probably have to be different, but this will get me going. So I'm going to just do an extruded loft on a different plane, on an offset plane, on 2 offset planes. So I'm going to offset by 5 inches or however many millimeters that is, and then I'm going to offset 4 inches and make another offset plane this way in the drawing, and it will just use the loft feature, and this will actually be done in less than, I don't know, 2 to 5 minutes in there, just to get me a lifted one, and I'll I'll want to see where it's just going to be a tube, just like a heating duct tube, just same concept. And then we'll draw on the plate. The plate we'll just use, we're going to have another offset plane, and I should measure what that is off of here at the bottom, so it's around 2 3/4. I'll get the exact measurements, and then I'll just simply draw a square out, right? And then I'll extrude the square. I'll just use the extrusion feature, extrude the square out a bit, and then I'll come back and locate the 4 holes that I need, right? And so this part, even though it looks complex, and what I'm doing is complex, if you just using your CAD program, doing some basic stuff, I'll have this whole thing ready to go. The more complex thing is going the 6-pin MAF, which will go right in this area somewhere. Well, one of the problems I have to solve for is getting this on there. So I took this off over there, went ahead and did the measurements. Both these shafts are 30 millimeters from bottom to top. It's amazing how much stuff is pretty similar for the same size engine. And so I'm not going to take this off. This is all pressed on there. And this is a bearing that's in there. And I'm pretty sure there's a bearing on the other side to give it smooth operation. And it's got this nice spring on there already, and the Merc spring was wore out. So I'm going to, before I section this part right through here, I'm going to test it out. And essentially, this is the old spring perch, which we don't need that anymore, but we do need this. I want to keep the geometry the same. And so if I section this piece off right through here and lay it up flat, then what we can do is drill a couple holes and here and here and attach it. But I think I'm going to make it, I'm going to model it first, and we'll put the model on there. And then I probably won't even cut this, leave it with the, and I'll make a carbon fiber part for it. So a nylon, a 3D printed nylon carbon, probably not nylon 6, with carbon fiber in it, 15 or 20%. Just probably using Carbon X stuff. I like their stuff. And then we'll put the throttle sensor back on. We will, let me pause this and take this apart for a second. Before I forget, one final thing I want to add about this. So on 77 and newer with the K-Tronic, with the newer stuff, with the newer system on it, 76, my car is kind of like the only year where stuff is like this. It's more, it's a split between 71 to 74 and 77 on up to 81. And the 77 to 81 does have a throttle position sensor. The only thing I don't know about it is the type of potentiometer that it is. It needs to be the one that's not a radial type one. And I think people have talked about that. It's not the right one, but I know this Ford one is. So, if you're doing your 77 to 81, you're going to have some differences there. All right. So I got this guy in there. It is taller. The Merc is 60 millimeters high, and the Ford is 88 millimeters high. So when I'll do my adjustments off of the measurements there. We'll use a silicone piece and knock it down to 3 inches here and on the drawing and stuff, and we'll use a new silicone piece to put in there. So we see it really needs to be like this. So if it goes on, it wants to be like that, but it's just not. It's not going to fit at all. And there is some other stuff in the well. I'm going to have to wait in the valley of the V8, and it comes up right here because then the water pump sits around here. And what I'm going to need to see is, you know, I know we got this piece here that I can, this is the part of the crossover, and there's the piece here, and then there's a water pipe that runs right down through here as well. So, you know, this is still to be determined. It's definitely going to be a piece that's going to be made. So this was the yet to be designed. I'm going to just get it to the CAD, get the shape into the CAD. And look, the gasket fell off, and I got a nice little piece I can scan to get some initial references. I don't even know if I'm going to scan it, but anyway, that makes it easier. All right, next time you see me, I think we'll be playing around with Fusion 360.